I was wondering that being oldest person in the audience, I presume, why I was called by Ariel and I don't know. But I realized that there is an advantage of doing science for 40 years, especially in a country which needed frugal innovation. So I saw hard the words frugal innovation, limbs replacement. We needed to do science, to sell built equipments, and lastly, to publish your own journal. And I was asked to talk on open source drug discovery way more than just science. So there will be less science on this article. It's a huge science. I'll tell you a story how you can transform the most complex situation and how can it be converted into an education system. Since we discussed about frugal innovation, I suggest that the Jaipur foot is an example of $28 fit, which is one of the best. This is the British Journal of Innovation on Nesta report. We also have, I think we talked about GE Mac 400, and there are similar, Cellco is another one, and open source drug discovery is shown to be one of the most frugal economic highest impact by the Nesta report. Why TB? Because TB kills even today 1,000 people per day in India and about 4,000 people in the world. It kills as many people, as many is killed by cancer, but just happen to be 400 molecules of cancer are in the clinical trial, whereas 2 or 3 are for TB. So we know when 100 molecule goes into clinical trial, a drug is guaranteed. The scare part is that drug resistance TB is now seen all part of the world. And the cost of genome sequencing has come down to $1,000, where the drug discovery has gone to about nearing $2 billion now. So therefore, the virtual cycle of innovation, investment, return model that pharma works on has broken down when there is a lack of market incentives for neglected disease, because the entire market for TB is $300 million. So it doesn't make sense to make a $2 billion drug for a $300 million market. So what happens in the process? In the process, what happens, 50 years no drug has been developed. The drug, do you have a pointer? The drugs, shown in red, the pyrazinamide, rifampicin, isoniazid, and ethambutol, is the last 1963. So this is the treatment everybody gets. It's only with, I'll say, the noise of open source drug discovery, the Bill Gates Foundation funding, there are certain activities you can see which have started appearing in 2012-13 and 2015. There are some in the pipeline, but still it is very, very small compared to. I was wondering why I said that frugal science, doing all science, when I can say 70s, out of 40 years of my science, 39 years I did in India and 1 year I did in France. And so therefore, you have to innovate yourself to do something when you don't have resource. So the resource limiting condition doing things is very difficult. And I'm so glad to see that I just tweeted to my son saying that I see a lot of young crazy people who are ready to change the world when I come to this building. Last time I came and I saw so many young people actually are crazy who thinks they will change the world. It's fantastic, and I believe we will change the world if the way all of you are thinking. Now, why this came? Because I asked this question, being a scientist who's been involved from the Human Genome Organization from 90s, being council member for 7 years, why this is the situation. So we launched a open source drug discovery, 2007, and crowdsourcing with a difference. Crowdsourcing has been done, even American Idol is crowdsourced, YouTube is crowdsourced. And it's nice to see that it's one of the earliest. So all the drug discovery is complex. We went ahead and crowdsourcing. So what was this program? It was collaborative aggregated collection of information. So the argument is, can we read everything that is available in literature of TB and build a system biology model, put it in computer, do simulations, and the way aircraft simulation takes place, by which today you don't do a trial and error prototype, you actually make it, That's just like one day, I'm sure this printing will be like that. I wish you can do a design and get it. So it has become a global platform, and we have more than 8,000 people on the platform. Now, why open innovation? I think I don't need this audience. The open innovation goes beyond the boundaries, and you can get talents whom you don't know. Today, OSDD, as open source drug discovery for TB, is a well-known globally. We have TB Alliance, DNDi, World Health Organization, all are involved. I won't go into the detail of the whole process. I'll tell you how this has helped in education of the system and how this is, it is beyond the research project. Just to give a science objective, as I said, the way aircrafts of 777 or 787, for those who have flown, you will see such a beautiful aircraft, but it's not prototypes. It is completely designed in computer, flown in computer, crashed in computer, then the first component of 3,300 components were manufactured. Whereas you go to Wright Brothers era, everything is trial and error, including 747 Jumbo. 747 Jumbo needed 2.5 kilometers of runway. There was no runway during late 50s. So they have to try it on water in the bay. So that first aircraft of 747 to carry basically Second World War materials. But drug discovery is still sitting in Wright Brothers era. Try and failed, try, chemists keep designing, you do an in vitro, then you get into in vivo, then you fail, and you come back. When you go to clinical trial, eventually preclinical trial, 100 leads to one molecule if you are lucky. But the fact is, Gleevec needed only 58 people to be clinical trials. It was such a fantastic discovery. So the fact, by serendipity, you had great discoveries, but with all this modernization and computation, we haven't been able to. So the idea is, how do I get everything into a computer, use it such a way, reduce the failure from 100 to 1 to 5 to 1. Then the cost will come down, and once you make such discovery, then you have generic companies, including Teva of Israel and large number of companies in India, who can give it cheap. Please remember, Israel is the largest innovating organization, takes large number of patents, but when it comes to healthcare, they depend on generic. And that's the smartness. Healthcare is a right for all. It is not, should not be a part of a business. And we are all going to suffer this world unless we make a difference. So what did we do? We looked at it and found 45,000, more than 45,000 papers are published on tuberculosis. This has to be read. If we really want to do annotation, and the Pasteur Institute in 1998 gave the genome sequence. 2002 there was a partially annotated, but so what? No drug has come in spite of that information given publicly free. So we collected thousands of students, 800 students to do this job, to read in the literature. So we advertised an open, collaborative, large-scale effort in 2010. By the time we realized that in order to do this exercise and fully, so are you an explorer, join us summer. I see the same excitements here. And it was done from there. We told the students, if you participate, you will have a chance to interact with the best people around the world. You will find your cure TV. You will receive a certificate of mentoring and maybe some prizes if you do well. This ad, when we put it up, most of the people say it's not going to work. It's all bullshit. Communication and management overreads a huge community. It will cost you, including Cell Press. When they wrote a very positive article, the last paragraph, some people said, this is absolutely crap. Okay, you can go back and see 2008 article. What we needed to do, we needed to create a community, train the community, create a Web 2.0 platform where they can communicate, self-organizing community, community-approved hierarchy, and motivate. And of course, you have Google Web, Google Group, and Doc. Originally, we started a teacher-student-like groups. I soon realized that most of the young people idea are rejected by older teachers. So therefore, we remove the designations, and students didn't know who is senior, who is less qualified. The group became different. Self-learning groups got evolved. We made sure we allowed posting using a PC, mobile, or a handset device because computers are not available in rural India so much. So annotate genes, manuscript by reaching short blocks. So students started reading and they start posting like this. And each of the annotation, each of the genes, 4,000 genes of mycobacterium from 45,000 published literature, you want to give biological meaning and all put into the computer. It created emergence of functional self-organizing group. There were students who were training freshers. Their job was only to train the freshers who knows smarter kids. Many reprints were not accessible, maybe 1/3 of them because they were on proprietary closing. So 3 students and then a group of volunteers wrote emails to 15,000 scientists to send reprints. So they created a reprint directory. They opened up a 24/7 call center, students, to answer questions of other students. And manual created by the students. Google Doc, the annotation started correcting. 4,000 genes were annotated in 10 months by 800 students. 45,000 papers read manually. There were fights and arguments. One will online will say, no, this is you are not right, you are right. So I just want to show you when there will be a dispute, the dispute will go on, then of course one of us will come in and solve it and say, okay, we will read it and check it and dispute is solved. Students came up with blogs, their own, and it was very interesting that it had participation from Malaysia, from Germany, and several parts of the world. And eventually, all the experimental evidences that are buried in literature were picked up by manually. Collaborative literature mining analysis actually allowed us to generate a computerized model of entire protein-protein interactions and the pathways. I won't go into the science of all those details. They are published. I just want to say, when 120 students were picked up, the last best people, they were brought to Delhi. A conference was organized. They could meet many, many scientists. A philanthropist from England came up and donated 120 laptop computers. So we gave these 120 students laptop computers. A laptop computer in India for a student is like getting a gold mine, right? What we did, we just printed a OSDD poster on the back of the computer. So when the student went back to the college, for every student who got a computer, 50 students joined the program. So we could build up from 120 to thousands of the students for the phase 2. Now, of course, there were model, people talked about it. Actually, others wrote about it more than I wrote about it. And I was quite busy those days. I wouldn't have been able to freedom to have 3 days sitting here. So therefore, it was, but it needed a very robust platform. So we built the platform. When 1,000 students started working, 1,000 plus, platform started crashing. So we went to the Infosys, the India's largest IT company, and I met the chairman and I told, I need your help and pro bono help. So the software would have costed us $5 million, but he did it free, helped us to free, and we just pay small money for the ticket. So this is all open source portal, and on this portal, we could actually annotate all the informations and eventually published an open source journal, all the structural annotations. We also published the entire crowdsourcing of the drug targets, the new targets, which are computerized targets, and this led to about 54 people. I can say 45 photographs I have. from 29 institutions. But what was interesting, there was not a single elite institution except Indian Institute of Science. Most of the students came from very small universities and colleges where they had no facilities. And they were very excited to participate. So our rule was, if you contribute more than 1%, then you become an author. Otherwise, you are a consortium author. So these are the students eventually. Actually, 20 of them, I've never seen them. I've come on Skype. So I invited them after the paper was accepted, at least let us meet once. Now, what is the educational value of this exercise? This is the educational value. We sent in about 146 candidates, which actually emailed. 92 has responded. You can see 36 of them are doing PhD now. That means in 2010 they were in colleges and university, and 12 of them are doing outside India and 24 in India. 20 of them got jobs in industry, and many of them are now become even a faculty. They were just PhD students. They did this, they got visibility. Because the portal, you will get everybody's contribution is marked. Now, what is interesting is, of course, Europe has maximum number of students. Here, 1 in France, 3 in UK, 5 in Germany, and 7, of course, in USA. If you look at how they have gone around from India, and these students would have never made it to any international laboratory by any conventional route. It's just because of their sheer performance on the portal they were picked up. Then we got into experimental. We wanted 120 genes to be, which are targets to be cloned. Again, one young colleagues of mine in Acharya Narendra Dev University, Inch College is a college where you use students to create 120 clones, proteins, which are used for target development. We got excited, 2011, we went on and said, why not the chemistry is done in the country? All the students, what did they learn today? We said purposeful science, right? We were responsible science. So can we make the students synthesize? And this is the library the students started creating, and hundreds of students, and if I show you, we spent about $2.5 million to create thousands, and this would have been a fraction of a money in a European Union fund. And I know the budget of TB, system biology of European Union fund. So this is how much could be achieved with how many people coming in together. And of course, we are not paying any salary to anybody, most of it. We realized that if we have to do computational modeling, we have to go to Schrodinger, and Schrodinger charges $20,000 even for an academic license, and $200,000 for a professional license. So we said we will build a whole generic molecular suite. This is open source for drug discovery, and the best minds of Indian science, I brought them with hundreds of students. We decided to do 57 million molecules computationally to screen all these targets. And you can imagine 57 million molecules is impossible unless you thousands of students. Again, we wrote down the protocols. We picked up thousands of students, and we signed with Royal Society of Chemistry so that any of the work can Royal Society gave it champions. 7 students were identified whose job was to go to 1,000 students to be trained, going from 35 sites. And eventually 1,000 students were trained in this activity, how to do molecular docking and chemoinformatics. Just to show you, when the students came, we had most, even by, you can see, very few was PhD. 5% was only PhD. The rest were not PhD at all. They came from various, and they came with all sorts of discipline. Today we have produced one of the largest, and you can see masters, BTech, MTech, BSc students, they have become expert in chemoinformatics. So we asked, where did they come from? And it turned out very large number came from very deep South India, okay, and from colleges and institutions which are less endowed. Okay, so there is a huge hunger, and we could get them from this part of this country. What did we get? I just want to show you 2 slides and say we got a new molecule with an improved docking on a new novel target which will be non-toxic based on the molecular, all the system biology. We also discovered that we can repurpose a drug called metformin along with TB, which is a NADH1 inhibitor, and thereby it can actually work along with the existing drugs. So these are discoveries done, but what is the outcome, as I said, beyond research? Today, we have a virtual laboratory created, a drug pharma company, all participation of students and all open laboratory space across the world, including Cambridge, SBI, DNDi, and others' participation. What have we achieved? We have open innovation from best minds of academia, about 100 laboratories. There are 115 contract research organizations, and it has also, with collaboration of TB Alliance, gone to the first multi-drug resistance clinical trial with 3-drug therapy. We have over 8,000, any given time, about 20% are active. Why I say this beyond, we realize now a drug to be taken into clinical trial, there will be huge objection. There will multinational, lots of companies will go behind. So we decided to popularize this and get patients. So we decided to put up a YouTube competition, need for TB drug. First chance, 180 entries. Second year, again, another 130 entries. And we gave them prizes. If you go there on the website, and each of them has been seen by thousands of people, so TB drug requirement has become it's like a carpet bombing. Any government official, anybody, you just have thousands and thousands of YouTube viewers. It just got popularized. So therefore, what did we learn? We learned the group fall in place. A good PI is worth a pot of honey. How do you make a group collaborate? The same folks together, and web finds each other. But PI has a job to do. Otherwise, the group will go haywire. When you do crowdsourcing students, you will not get a result. Need to guide the flock. If the task is challenging, they know when they cannot do. And when they cannot do it alone, they collaborate. And therefore, a structure takes place even in a chaos. This is a festival in India. So short term versus long term, I believe incentive is a short term, motivation is long term. Therefore, less endowed students gets a chance. My job was to ignite the minds and give them a dream. That dream transform into thought, and thought into action. And this is what my younger colleagues then participated. So I believe there is a new need of paradigm shift in education system. From teaching to mentoring, from teacher-centric pedagogy to learning-centric pedagogy. I don't have to tell this audience. This is how we are going to make a difference, from creating islands of excellence to creating sustainable ecosystem. And therefore, I think I have a responsibility now, about 90 million people of the state of West Bengal, to look at their education system. So this also attracts me to this audience, just to learn from you. And of course, I believe the education should stand on excellence, employability, inclusiveness, and value base. The most important role of a teacher in the modern world is to identify the talent students. It could be a baby, an opportunity to facilitate exercise such talents and attain excellence. What is interesting, 100 years, 130 years back, Vivekananda has said, education is the manifestation of the perfection already in man. It is the manifestation of potential perfection, the infinite possibility of the human soul, for which the teacher and the environment act merely as catalyst. Vedanta, which is 4,000-year-old, says that within man is all knowledge, and it requires only an awakening, and that much is the work of a teacher. You know, it has not happened. It has happened with large number of talented minds who came together, who believed in it. Of course, to start with, I had only 2 disciples, and slowly as we moved, more and more people joined. And I thank Professor Tom Blundell from Cambridge. And I believe when it comes to health, we need to have a balanced view between health as a right and health as a business. Thank you.